Okay, MVF G5. So this problem is a combination of techniques from this section and also techniques from the previous section. And by the way, very often that's the case. I mean, the students tend to think of exercises as always pertaining just to the section. Not that you were, but so here we're going to be combining techniques from different sections. So the graph of this function f is represented by an equation, and the equation is z equals, so here's where we're using the graph construction, z equals, and then I write down the formula for this thing, and it's e to the power of x minus 1 squared plus 4y squared. Okay. So what I really want to know now is how do I draw the solution set to this equation? Okay, well, golly, what do I do with this? Well, I could bend and stretch this around, translate, etc., and get that to turn into z equals e to the x squared plus y squared. Right? By a couple of translation and stretches. Is that okay?
So it doesn't matter that the e's there.
Oh, it does. It does. Yeah. Right. Absolutely. So the question is now, what does this thing look like? And again, we don't know, right? But this is a rotation of something. This is a rotation of z equals e to the x squared, sitting inside of the xz plane, with x positive, around the z-axis. Right? So that's sort of our starting point. So we're going to start off with, there's a multi-step process here. We're going to look at, in the xz plane, with x, oh, did I get this backward? Let's see here, x squared plus y squared. Yeah, in the xz plane with x positive, in other words, over here, we're going to look at z equals e to the x squared, and that's, roughly something like that. So it's a very quickly increasing curve like that. Is that cool, huh?
Okay, so you got rid of the y squared term just because we're looking at half plane 4.
Yeah,
okay.
That's right. We're looking at so this half plane here is defined by y equals 0, x positive, and that makes this turn into this. Yep, exactly. So, but the good news is, I've taken this problem that oh my gosh, what do you do? But we know that we can bend and stretch and twist, translate, etc., to make it look like this. This is a rotation of that, and this is a curve in R2 that we know how to deal with, namely it's that. So I'm going to take this curve, I've got to rotate it around. So that's, what you get when you rotate that around the z-axis. This rotation, then, I've got to bend and stretch appropriately to make it look like that. And that you're just going to use the techniques from the previous, the previous section. So this one here has equation z equals e to the x squared plus y squared. And if I want to get this to look like that, I've got to replace x with x minus 1, and I've got to replace y with 2y. And so that's going to take this surface here, we're going to translate it by 1 in the x direction, we're going to squish it by a factor of 2 in the y direction, and that's our result. Yeah. So combining a bunch of different ideas here all into one, yeah. And this, what I like about this example is, you just look at this thing by itself, you're like, oh my gosh, it doesn't have any of the, it's really not clear how you would draw this picture. But combination of techniques, and you can do a lot of different things.